Okay, hello everyone, and welcome back to Archaeology with Flint Dibble. And I am here with a good friend of the channel, Dr. Sarah Parcak, at the University of Alabama and in Birmingham. And and so we're going to be talking about this conspiracy that has sort of rocked the interwebs. Everybody's kind of seen, I think, by now, this kind of pyramid megastructures underneath the pyramids. And I kind of covered a little bit of this and some of the wacko-ness in a really impromptu live stream last Friday, where I sort of said, hey, we actually understand the bedrock and the geology and the hydrology of Giza, and like this team needs to overcome all the evidence we actually have. But I thought, look, I am not an Egyptologist. I am not someone who does remote sensing from satellites. And well, that is Dr. Sarah Parcak. She wrote the textbook on satellite remote sensing for archaeology, and a lot of her research focuses on Egypt. And so, so I thought that this would be a great opportunity to try to get somebody who knows a lot more about these topics to really introduce them and discuss them in a little bit more depth. So thank you for coming on, Sarah. I really, really appreciate it.
This is awesome. I'm super psyched to talk through stuff with you and your audience.
Good. And so, I mean, like I imagine when you see these kind of images, your hackles are immediately sort of raised with this kind of artistic reconstruction from something like that.
So what's crazy? So I had a super busy week. I was working on a big proposal, and obviously very busy with universities, working midterms. So I found out about it. Like my phone had blown up, and a bunch of people, both family and people who were a little bit into archaeology, started texting me like, hey, so are the pyramids built by aliens or what? I'm like, what has gone on? I didn't know. And then got online and saw the news, and it was like, what? And I wasn't aware at first just how like hyper viral this had gone. I guess Alex Jones retweeted it or talked about it, and then I guess Joe Rogan has talked about it. Like, I mean, explode, like
it just, it went viral immediately. I think it was mainly because, as far as I can tell, this guy Greg Reese, who has a connection to InfoWars, made a blog and a video post about it, an AI video post, and that got picked up by InfoWars. Then this other guy, Jay Anderson, who we'll look at one of his tweets a little later because he tries to summarize the methods, I guess. And yeah, it just went mega viral. I found out about it because one of my good friends from high school, who's a very smart, sane person, was like, what do you think about this crazy stuff under the pyramids? And I'm just like, what? And then I start seeing it just all over the internet over the next few days, that it was like, this is going to become a conspiracy that we're going to have to tackle over the next decades, really. I had a conversation with Milo Rossi about it, and he's like, yeah, this is going to be something that happens. But what's amazing to me is how old this is. People have been saying this, that there's a subterranean city under the pyramids of Giza for decades, and saying that it's a cover-up. And so, I don't know, people just want to believe, if you know what I mean, right?
My favorite conspiracy theory, and I feel like I can talk about this because I've talked about this with the king of the pyramids, Dr. Zahi Hawass, who, by the way, is absolutely a lovely, lovely gentleman. One of the times I was in his office, it was like one of these conspiracies had broken again, and someone said that there was like a secret chamber running from the Sphinx to his office. He's like, I would love that if that were so much easier, but like, who are these people? Going on
It's
forever.
like Hogwarts. Yeah, I know. And I mean, just to give a quick, something I didn't cover is also the lead researcher, if you will. He's a PhD chemist. He's published Real Chemistry, but these are his books, which are about aliens and demons and UFOs and things like that. So you can see, if you think we're getting started off in a biased way, the people presenting these results have demonstrated their biases as well. Everybody has biases. I think it's best we just acknowledge that. And these people are as biased as anybody else. So with their preconceived notions of aliens and demons and lost cities and things like that. So one of the things that I thought we could start with is just your article on the evidence that you use from satellite imagery and aerial imagery for looting in Egypt, because I think that it's a really important article because it shows really quite clearly how this kind of technology works, and what we can do with it. So you're documenting large scale looting. I mean, so how does satellite imagery sort of let you do this in a sort of systematic way?
So right, so satellites, there are different kinds of satellites, which we can get into over the course of this conversation. But most of the satellites that my team and I use in countries like Egypt, which, we're lucky, it's pretty deserty, and most of the sites are open. Obviously, there's some vegetation, some palm trees on sites, but they're pretty easy to see from the sky. It's called passive satellite imagery, and that means that the satellites are recording light reflected off the ground. And we'll get later imagery, which is in the category of active satellite imagery. And that means that active satellites, whether they're sending down pulse beams of light or recording energy waves, the satellites themselves are having to, or imaging platforms are having to generate that energy. So with passive satellites, they do a really good job of allowing us to see visual data, or data in different parts of the light spectrum, which of course we can't see. We can see in the red, green, and blue parts. Extends to the near, middle, far infrared. And, in a lot of instances, satellites are think of them like a space-based, MRI or X-ray, where, in some, with the active satellites, you can actually see beneath, but with the passive satellites, we're looking for very subtle differences on the Earth's surface. So with looting pits, Egypt has undergone looting thousands of years. King Tut's tomb was looted. The burial party actually snatched things on the way out. Howard Carter noted in one of the unguent jars, like a hand mark, or someone had scooped out the whatever was in there. So this is not a new activity. Yeah. But looting's been going on in Egypt and Peru and across the U.S. everywhere since people have been able to loot sites. And so really, I got into doing looting mapping in Egypt around the Arab Spring. I've been working there for more than 25 years now, and always been tracking sort of modern development and site impacts for site management plans. But really, around the time of the Arab Spring in 2011, there were all these reports of World Heritage sites, UNESCO World Heritage sites being looted. And we, of course, were working very closely with the Egyptian Ministry of Antiquities and National Geographic. And we were able to get very high resolution satellite imagery courtesy of Maxar Technologies, which is the imagery you see in the paper. And we just to test, right? We hear evidence of looting at sites. Is there looting going on? And I was very lucky. I just wrapped up a big TV program working with a BBC and the Discovery Channel, and we had pretty large satellite data sets from 2009 and 2010 of the impacted areas. So Saqqara, Giza, Dashur, down to the Fayum. And anytime you're making claims with satellite imagery about what's there and what's not there, of course, we have to look through time. What are the changes going on? 2009, 2010, some looting, but not a big deal. I mean, obviously all looting is a big deal, but not at a significant level, similar levels to what we saw before. And then when we compared the 2011 imagery from March and May, we saw a massive uptick. So that to us showed, that there was significant activity going on. So I had the chance to process the data. I got to go to Egypt, and I actually got to do a presentation at the Parliament building to about 5 different very high-level ministers. It will remain the most terrifying experience of my entire life. Oh my gosh. I did give part of the presentation in Arabic, which I didn't know if I should do, but it was totally the right play. Obviously very grateful to Dr. Hawass and others for letting me to share that data with them. But that really kicked off this study. So the question was, because, look, in archaeology, a lot of the pseudo-archaeology folks say like, oh, they're just not critical of themselves. They're high on their own supply. But we like to test things. We're all nerds. We want to see if things are true or not. And so the hypothesis was, looting has increased since the Arab Spring. Ergo, if we do a systematic countrywide study, or it seems to have increased at these World Heritage sites, ergo, if we do a systematic countrywide study, open source satellite imagery analysis, see a significant rise. let's put this to the test and see if it's true or not. So we went back and looked at Google Earth open source data. I mean, to get new satellite imagery and getting all the data for Egypt going back, whatever, 12, 13 years. I don't know. I don't have that much Bitcoin. So I couldn't have afforded it. I don't think it was worth much back then. I should have bought it back then. Then I'd be in a different situation now. Anyway, so we started in 2002, and we had a comprehensive GIS. So that's a geographic information system, which means a full site database for every archaeological site in Egypt. And we also had the many hundreds of other sites we'd mapped that weren't in current Ministry of Antiquities databases. So we looked at every single archaeological site in Egypt from 2002 to 2013, 2014, which is when the study concluded. And we counted looting pits. That's the image that you just showed, the little red circles. We zoomed in on each individual site, and we looked at each image over time. Now, full transparency, there wasn't data for every site for every year. Some years we didn't have data. Some years we had really good coverage. But in the years that were gaps, we sort of extrapolated. In other words, some sites, things didn't change a lot. And then 2011, 2012, they spiked. Okay, that's a post-Arab Spring response. Versus sites, we don't see a lot of activity. Maybe there's a lot of activity in 2006-07, but they look the same in 2014 or go, okay, from 2009 to 2012, there's nothing that's happening. So then we counted every looting pit. We looked at bulldozing. We looked at site damage. We had very detailed Excel databases. So this is the thing, like most archaeology is like this, as of course Flint knows and many of you listening know. It's nitty-gritty details. What does the data tell us over, large, this is a big data study. We look at thousands of data points. And I think we mapped, it's close to 300,000 looting pits at almost 300 sites over this 11, 12-year period. I mean, huge data sets.
Yeah, it's just amazing. And I mean, it's depressing, but I think there's a few important lessons, and this is why I wanted to bring up this study first. One of the things that I wanted to show people was the images you showed of ground truthing, like seeing this pit on satellite imagery and then actually getting an image of it to show that what you saw on the satellite was there on the ground. And then the second point I wanted to make was just sort of the relationship between looting and this kind of civil unrest, because looting is what you see those granite vases on YouTube videos. They're either forged or looted, and so they're looted from this kind of industrial scale activity that fuels YouTube pseudo archaeology videos. So I thought that was an important point to kind of make. Yeah,
totally. Yeah, I mean we absolutely anytime we do any remote sensing work, we absolutely have to get there on the ground and confirm what is it we're seeing. Or, obviously we can't, it's impossible to survey an entire country. So then you survey a subset, right?
Yeah.
Here are 10 examples of the 10 features we're most likely to find. They're either there or they're not. What are the discrepancies? What are we seeing on the data versus what's on the ground? And being honest about what we're finding and what you're not finding. I've certainly had instances. I tried times when we did a big project and we went on the ground and we did investigation and what we thought was there wasn't there. Well, that's interesting too, right? It's okay to not win or not have a definite result, because then what we do is we refine our methodology. Maybe we need to do different approaches, or maybe that doesn't work there. And then, looting is a huge problem, right? You go on eBay, Facebook. There's so many things that are being looted, and you can see very clearly what happened. And the interesting point, which is like most excited about as a social scientist, we asked the question, did looting increase after the Arab Spring? And the answer is yes, but not for the reasons you think. The reason looting was bad is because it was already bad. It started to get worse in 2009, 2010 because of the global recession. You see spikes with youth unemployment, devaluing of the pound, decrease in tourism, all these things that would make people loot. And it got bad in 2011 because the ground had been laid. So again, for your people listening that are skeptical of people like you and me, we're looking to really figure out what's going on. And you need all this big data, and you need to be critical of it, and you need all the groundwork to be able to put the pieces together. And the story often is very different than what we would otherwise assume, and that's important.
Yeah, I agree. And just to give an example that I thought was funny from about a decade ago, of the importance of ground truthing is there was these headlines of this teenager who found a lost city in
Oh yeah.
like
Yeah.
a Mayan lost city, and it turned out it was actually a cannabis field. And so they're using satellite imagery, and they made a mistake in identifying this feature. It looks like it could be an archaeological feature, even just looking at it. But when you go and you ground truth it, there might be other explanations, if you see what I mean, for such a rectilinear feature that shows up. And so,
Oops. Poor kid. I
yeah,
mean, he got excited. Like, you want to encourage it. And
yeah,
again, for the people listening, like, our job is not to dampen enthusiasm, right? Like, it's great. Okay, he should take remote sensing classes. He should learn. He should keep going with his interests. But I think, again, his advisor failed him. And of course, teen makes great discovery. Like, anyway, yeah. Never
yeah,
mind.
no, for sure. It's okay. So do you want to share your screen and walk us through some examples of remote sensing? One of our big goals here is to give people the background of how this works and the background of
Sure.
the field, and we'll slowly move towards the specific methods that team used to make these sensational claims.
Sure.
Yeah.
So what we want to start with is kind of how satellites work. So what satellites do is they record information. Basically, satellites work by, as I mentioned, passive satellites work by recording information reflected off the surface of the Earth. So this is our famous archaeological site called Tanis, which everyone knows from Indiana Jones. And you can see the large, it almost looks like South America sort of tipped on its side. So here you have the main site of Tanis, very large temple complex. There are pharaonic burials found there just before the World War II. Site dates to around 3,000 ago, so 1000 BC. And we were interested in this part of the site down here, which is the main settlement. And when you walk over the site today, it's brown. We always joke that, documentary people always think Egypt is too brown to feature. In this case, it is. It is just brownness everywhere. And so we got very high resolution satellite imagery because it was a great place to test. Does this actually work? And so we processed it. So you can see again, there's some of a few lines that are there. But as we zoom in closer, you can see processing. All of a sudden, we can see the outlines of most of the city. This is not really visible visually. And so what we do with the satellite imagery is seeing what's beneath the ground. Satellites are seeing very subtle differences on the Earth's surface, depending on moisture differences or building materials that you can see on the surface. And we're using pretty standard remote sensing techniques, looking at the edge, near infrared, and drawing out these differences. So kind of like space-based subsurface remote sensing, although you're seeing what's on the surface. Technology, of course, works differently in different places. Mm-hmm. So this is by my dear friend in Cambodia at Angkor Wat. And he is the field of remote sensing, both in Southeast Asia and generally by showing how LiDAR data can be used. So this stands for light detection and ranging. It's a sensor system that's flown on airplanes or helicopters, or it sends down thousands of pulse beams of light. And the challenge with Angkor Wat and most places in Southeast Asia, which you can see up here, is it's covered in vegetation. And so the LiDAR is able to create what's called a bare earth model. And all the information you see is the structures that are beneath modern fields or dense vegetation. And he was able to provide and create detailed maps of what these temples look like and all the people that live there. And that's the same technology that my colleagues, Marcella Canuto, Francisco Estrada Belli, have been doing with their really also very groundbreaking work in and around Tikal in Guatemala, where they've been able to map tens of thousands of new features and hundreds of previously undetected sites. And this other great example, sort of similar-ish to what we did at Tanis from the Venice Lagoon, again, looking at different parts of the light spectrum and revealing hints of what's there. So anytime we do satellite imagery, it's like we're throwing the kitchen sink at the data and really trying to figure out what's there, right? It depends on the landscape. It depends on the what we're trying to find. We never start a project with a preconceived vision of what's there or is not, right? We're building up detailed GISs of all the previous work, maps, excavations. We're talking to colleagues. we're really trying to get a sense, okay, what we might anticipate finding? Tombs, settlements, walls, river courses. We're interested in environmental change, or a site risk assessment map because a dam's being built and we want to see what sites could be impacted. So really, anytime you do remote sensing work, you're collaborating, you're working with a team, you're getting feedback. And the other really important thing, and we'll talk about this as part of the study. Look, I am an Egyptologist. That is my bread and butter. It's what I've studied for all these years. Obviously, done a lot of work on the classical world because that touches on Egypt and part of my PhD was on it. But I am very clear about what I know and what I don't know. And anytime I'm working in an area that's outside my area of specialization, as fun as it is to read about the Maya or the Vikings, or whatever I'm working, I will bring in collaborators. Hey, here's, here are great papers. Here's here's all the papers we've written about this site. And I'll familiarize myself. And as I'm going, I will collaborate very closely with them and get their feedback. And that will influence how my team and I are interpreting the data. And so talk about this, as we get into the paper, but the gentleman who co-authored the 2022 paper or who just came out with this study, then neither of them are Egyptologists and no Egyptologists were involved in that study at all. So that's a really important point to make.
Yeah. And they're also, so I guess we could start moving towards those methods. And I thought a really good example is something that I mentioned to you before we started recording, which is a study that you did outside of Rome, or you participated in outside of Rome. And it was of Ostia. So the portus, the port of Rome, right outside where all the ships went. This has been subjected to major remote sensing work, including a really multidisciplinary team led by the late Simon Kie. And it's involved magnetometry, ground penetrating radar, to be able to really show what's still left unexcavated. And it's really groundbreaking. And it included you with the sense of satellite imagery, right? I'm guessing that's what you contributed with. Here's some of the cool examples of how there's so many different methods that are compared to be able to show what exists. Do you remember this image? Do you know what the different images are that we're seeing? Yeah.
Right. So this is, again, part of a television program working with the BBC. And so introduced to Professor Key and then Chris Strutt, who is a specialist in landscape archaeology and ground-based remote sensing. The question we had was, okay, Portus is this city connected to the Oceanic Basin just outside Rome's Fiumicino Airport. It has been one of the more intensively studied in the ancient Roman world. So the question we thought was, okay, can satellite imagery potentially with rigorous analysis and collaboration discover anything that the team might not know about? So it was really interesting test of the technology. So we used digital elevation data, which you can see up here. And then we had a very high resolution Worldview 2 satellite imagery. So this has a 0.5 meter resolution. And in the fields, I remember I did a big study with my team. I was so excited. We found, 30 different things. Old roads, structures, old waterways. I'm like, yes, we did it. And I sent it to Professor Key. He's like, yeah, we know all of them. And I'm sorry, that's a paper I didn't send to you. I was like, what? And he's like, but good job. You didn't know they were there and you found that they're there. So the methodology works. I'm like, but there's nothing new. He's like, go back to the drawing board. I felt like I was working with my PhD supervisor. He's such a good guy. So, but the good news is we knew what techniques worked because of that.
Yeah.
And so we were able to go back, do more refined work, apply different methods, different techniques, different approaches to try to tease out some things that I had initially dismissed with my team because I'm like, they're ambiguous. But one thing in particular kind of jumped out when we redid the analysis, and that was this ovoid structure located in the fields. And it had these linear things running off them that looked like roads. So with more and more and more analysis, we actually started to be able to see what looked like almost a ring and some potential builds to the north. And I said to Key, and he's like, that could be the amphitheater that we've long suspected, the amphitheater that we've long suspected could be there. And we've heard some rumors and we weren't sure about it, but that looks super promising. And so, so that was the study. And obviously not my project, that was under his direction. And he said, in future, they wanted to do more detailed work. And I guess later on, he found out that the farmer who had owned those lands had actually known that it's really naughty in Italy. If you have something on your lands, you have to inform the government. And he knew it was there. That's a different kind of ground truthing. I was glad I wasn't involved. It sounded like, oops. Anyway, yeah, it was a super cool study.
And relevant to this is while I was doing some research to talk to you, I was doing my own little research into synthetic SAR, synthetic aperture radar, right?
Yeah.
Yeah, so I was doing my own research on it, and I found this summary article, in a sense. It was summarizing a range of different studies using recent SAR data in archaeology and how it works. And in there, they had a whole section on using SAR for this osteoportus area, and that ovate feature you mentioned. Sorry, this is another image, but I do want to point out, before we go into the detail of SAR with you, I do want to point out that what this study at Osteoportus did is they were identifying subsurface features from the SIR data that showed for crop marks. So in a sense, different crops grow. They grow differently when there's buried architecture underneath them versus when it's not. And guess what? They found your ovate feature right here again using SAR data. So it shows that it all lines up, that using SAR data to look at the type of crops that are on the landscape, to look at subsurface stuff, it matches up perfectly with what you found several years before that. And so it shows that SAR does work, but it's not penetrating very deep. It's doing kind of vegetation. So maybe we could talk a little bit about what SAR actually is?
Sure. And by the way, like this is the stuff I love, and I'm so grateful to Flint for pointing this out, because I didn't know about that study, and that's something I want to include in my classes. We ultimately have to be really critical of all the technologies we use, because as I said before, sometimes they don't work, and sometimes multiple sensors will show what's there, give additional insights. So SAR data, any kind of radar data, is really useful and helpful for all the work that we want to do. So there are different kinds of synthetic aperture radar data sets, and it's different than active satellites in that there are radio waves that are sent down from the actual satellites, and there are different wavelengths that penetrate the ground or have different responses. So the L is the shortest, and that tends to have the best resolution. And the other wavelengths, so there's C and there's M, they're longer. And what this is super useful for is looking at like geological fracturing. So it's really important. So for example, if you're a geologist and you're interested in terrain mapping, where there are different deposits. So this shows different parts of the light spectrum and where different bands of information are located. It can be really helpful. So yeah, and that image showing the tree. So the big challenge with radar imagery is noise. Mm-hmm. It's very fiddly. Of all the satellite data sets that I have worked with over the years, I have struggled the most with SAR data or radar set data. It's just because radio, right? There's radio waves, there's speckles, it's hitting, anytime you're dealing with active satellites, it's hitting lots of features. So trees, ground cover, buildings, whatever is there. And what the satellites, what it's doing is you're sending the radio wave down, and it's measuring the bounce back at different rates, intensities. So for example, if there's something just under the ground, I'll try to angle my, maybe it goes here and then bounces back versus the others that are bouncing here. Okay, so there's something unknown, maybe. But it can only see up to a depth. The L band can only see up to a depth of 2 meters. And that is in perfect conditions, like perfect. So for example, let's just say that there's a 2 million year old riverbed buried beneath a desert like the Western Sahara of Egypt. Radar data has been used to map old river courses buried beneath sand, which is great, right? You have sand and then you have rock, and it's seeing through the sand, maybe a bit deeper, but again, there's no interference, there's no buildings, there's no wires, there's nothing, and it's dry. versus a site like Giza or any site that's next to more modern sites. Giza is dense rock. And we also have to look at the resolution, right? And so resolution plus noise, and it's easy. It is so easy to overinterpret satellite imagery. Guilty as charged, Your Honor. I have done this before. I have gotten things wrong. So for all the guys out there who are like, yeah, but we looked at this thing and you were wrong. I admit it. I have been wrong. This is what science is. We test, we get wrong, we go to the field, it happens, we own it, we write papers about it, and then we keep pushing ahead. That's good science. But to do something and then almost willfully misinterpret it, like I could get any satellite imagery to look almost any way I wanted with enough manipulation. I am that good at it. And it scares me because that's why I'm so careful. I never misinterpret, because you calculate things with the software, with weighing pixels, oh, well, you don't see anything there, but trust me, it's there, right? Because it's the guise of the expert. So I think that's what these guys, they've done. They've willfully misinterpreted the data. And the satellite imagery, SAR data can't see through rock, period. The end.
So this is what
this does not work.
This is the article you sent me actually over WhatsApp before I did my live stream. And so, so one of the things I learned from reading this is that SAR has been around since the 80s. It's a really well-established method. It doesn't penetrate more than 2 meters, really, and especially with rock and other things like that, which, as we know, the Giza Plateau is right on bedrock. So, it's like it can't penetrate. So this is their explanation. I want to know what you think. This was what I saw on Twitter just today from one of the guys who's been communicating a lot of this. And what he says is he's seen a lot of social media critique that SAR does not go deeper than 2 meters. And he's like, that's correct. But what they're doing is they're actually recording the resonance, the acoustics that actually exist in the rock to be able to detect voids and other features. And so here, let's listen to a member of the team rather than this social media guy who's been rah-rahing them on. And let me see what you think about what she says. I think it's auto-translated from Italian, but...
Part of the Kefren research project, Dr. Armando Mai, Professor Filippo Biondi, and Professor Corrado Malanga have invited both Italian and international press to a special conference, held both in person and online, to reveal the results of an innovative and groundbreaking study that has redefined the boundaries of satellite data analysis and archaeological exploration. During the press conference, for the first time ever, structures believed to correspond to the legendary halls of Amenti will be revealed. Using synthetic aperture radar (SAR) technology, combined with the new Doppler tomography methodology, the research team has made a series of unprecedented discoveries, located precisely beneath the Giza Plateau. This technological innovation involves converting photonic radar information into phononic signals, vibrational data within the acoustic band, thus enabling the exploration of deeply buried structures beneath the Earth's surface.
So, okay. So, from what
Hold on a second. Wait, I need to capture some information from the vibrational forces to see voids. Hold on, wait. Hold on. Thank you. Sorry, I just had to. Yeah, I had to. Yeah, that's real interesting.
We should splice in the clip of Graham Hancock saying how they moved the stones with resonance by moving. This is a real common theme in a lot of pseudosciences. There's these vibrations that sometimes can be unlocked in different ways, and in this case,
there's some vibrations that can be unlocked. There's a website in California that has a range of vibrational tools. I think some more people need to use them. I'm going to get into so much trouble.
So I mean, is this a method that has been demonstrated in any successful way archaeologically?
Archaeologically, sorry, different. It's the X band. It's the XXX band anyway. I nearly got spit on your screen. Yes, achievement unlocked. Yeah, so I mean, it's like they were stacking all these words together, and like individually, maybe each individual thing works in its own way, like sonar, right? Like we know sonar can work beneath the water, and again, that's a separate field, and it's complicated and requires a lot of scientific knowledge. Like all these things together, you know, SAR measuring the vibrations. What vibrations?
Yeah,
Where?
they claim that different rocks vibrate in different ways, and somehow when you beam this radar off of it, it's able, from different angles, it's able to detect this different acoustic vibration, but not just on the surface or right within the area the radar bounces back from, but somehow from 2 kilometers down.
Right.
So this is, yeah.
You know, full disclosure, I'm a geologist, clearly, but also my business is rocks in part. So I've taken geology classes. We have a project geologist that works with us in Egypt. I collaborate with geologists. You know, I don't know about rocks. You have to know about rocks, generally speaking, to be in geology. And I've certainly been at Giza where tours come in, energy tours, and people will go into the King's Chamber, and it's actually it's really cool. Like I've meditated in there while singing, believe that it will, I don't know, connect me to the gods, but like the chamber has amazing resonance and sound. Like there's legit academic peer-reviewed studies that look at resonance and its impact on brainwaves. Like I tranced at a temple in India. It was amazing. Again, I don't think it's crazy or otherworldly or connected to aliens. Like it has to do with how ancient people interacted with acoustics.
Oh, for sure. There's lots of
which amazing stuff.
Studies.
Right. So I want to acknowledge that because that's important, because that type of resonance is super important for understanding ritual and religion and song and ancient practices. So I've been in the King's Chamber at Giza where people have come in, and it's been really cool. And sometimes I go with my team members. I have an okay voice. Some of our team members can sing really well, and we try to harmonize because it's beautiful. But like, that's not this. Like you touch stone and it's stone. Like that's saying that the stone is vibrating.
What's even more crazy, let's go back to that big long tweet by Jay Anderson, is they claim that the Giza Plateau is unique for this. It's perfect for detecting this resonance. Why? Because it has limestone and granite there. And I'm just thinking to myself, man, landscapes all over the world have limestone. Maybe demonstrate this with stuff that's known that you can ground truth it, rather than like claiming his crazy results first.
Okay, so let's be like, if we were to test this methodology for real to see if it contains any truth, right? Let's go to places where we know there are massive voids beneath the ground. So I don't know, where there's nuclear deposits in like Nevada or wherever they are, or deep underground chambers wherever in the world. Mines, right?
Yeah.
Can we see? And you know what? Here's what we're going to do. We're going to tell the researchers that in this, 20 by 20 kilometer area, there are a certain number of mines. So if they want to prove that their methodology works, there's no mining information given to them. Do it. See if you can find what's there. Kind of like what I did with Professor Key, but in the backwards way. Like I found all the stuff that he already didn't tell me.
And kind of like what that SAR team at Portis did with your data. They found your ovate feature using a different method to be able to ground truth it. And so, yeah, exactly.
So fine, fair dues. Let's try it somewhere else. And if it works, well, okay, we can talk about it. Aside from all that's ridiculous part of it, like nothing connected to anything ancient we'll get into, but like, it's also just bunk science. Like I read their 2022 paper and I kept having to reread because I'm like, how are these? This is pre-ChatGPT and it sounds like ChatGPT. And what's crazy is the guy who is the co-author, he seems to have done some good remote sensing work looking at dams. As far as I can tell, I haven't read those papers in detail, but they don't like looking at like dam movement, which again, it's like you're figuring out how much structures have moved on the surface over time, which is a pre-use of SAR from everything I understand. So he's done legit remote sensing work. So I don't understand why he would do something like this, because up till this, it seems like he's had a pretty solid academic career doing pretty standard stuff.
What did Jason Colavito, I thought, wrote about some of his beliefs? What did he say specifically? Sorry, let me see if I can find it. He mentions the 2022 thing. So, yeah, so Malanga, who he mentioned, he has that demons and UFO stuff. Armando May believes in a pre-dynastic lost Egyptian civilization. Filippo Biondi has previously promoted a harmonic investigation to Khafra's pyramid last year even. So when you click on here, it shows all this kind of strange acoustic stuff, which I guess is a premonition of what just got released. But I mean, it seems to me like, I'm working on a video that's sort of like the 5 key tells of pseudoscience in today's world. And one of them is going to the public before trying to publish stuff in a peer-reviewed journal. I mean, I know I've critiqued actual scholars who do this, which some of these people are actual scholars, maybe not in these fields necessarily, but like, it should raise your hackles as soon as you're trying to appeal to the public rather than other scholars who are familiar with this methodology, people like you, if you see what I mean, because then you end up with these kind of results that are absolutely fanciful, and you end up getting on Joe Rogan and Alex Jones. But what is this noise here that somehow creates these fancy artistic drawings, if you see what I mean?
So here's the other thing, and I teach, I've taught introductory remote sensing at U for almost 20 years. And one of the things, you kind of go step by step and you learn different levels of different approaches and different techniques. But about halfway through the semester, I'm like, right. So today's class, the theme is LSD, because that is what you will see if you interpret the satellite imagery the right way, and if you choose the right cool color drop-down menu. So what you can do with your data is, because it's all false color image part, unless you're looking at it visually, you can pick themes you want. And what I tell my students is, generally speaking, try to pick the color schemes where like earths are brown, vegetation is green, water is bluish, just to have some approximation, unless you're really trying to emphasize very specific features that are otherwise hard to see. Then you can go crazy and pick something that's going to make something pop. I've done that before just to highlight something.
Yeah, of course.
But like anytime you see anything that look like a Burning Man party, it's so easy to manipulate data. So if there's the most subtle differences in the pixels that scientifically are meaningless, you can weight the pixels to get them to appear that way.
Yeah, no, that makes sense. I've done a lot of GIS work myself, including some with satellites. And I mean, and I do a lot of statistical analysis. If you really try really hard, you can manipulate your data in ways that somebody needs to go into the details and look at it and understand what you did and then be able to sort of call it out. So, I mean, I guess so they're going to do a bigger press conference at some point in the coming weeks. Is there anything that we convince you that this is legit in any way?
So, okay. So, Flint very kindly came and spoke to my students a couple weeks ago, which they loved. And my teaching a course on archaeological books right now. So this is like a super current thing that I'm kind of glad it happened, because now I can teach about it next week, because it's all happening in real time, and I can get my students to teach it, because ultimately we want them to be able to think for themselves. Okay, so we always ask the question, right? Who are the authors? Who are the people behind? What's their purpose? What's their background? What are their biases? Where are they coming from? What are they trying to get out of it? And the main point is both of these guys believe that there's this mysterious pre-civilization, that UFOs, I read the 2022 paper, and it's in a really good journal that I've published in called Remote Sensing. And the problem with that journal is that sometimes they get paper slip through, and the paper clearly slipped through and it wasn't reviewed by an Egyptologist, because an Egyptologist would have said, this is scientific bunk. It can't, aside from the remote sensing stuff, like it's bananas.
They actually published the reviews, right. And like there's just a few little things. Reviewer number 2, this is very well done. The equations put me off a little, and I have no idea what to make of those, but the modeling was super. Good job. That was the entire review.
That's ridiculous.
And
I
it's
spend
like,
like days. It takes me days to review papers. We're like
yeah.
pages of comments.
And on top of that, they got this published within less than 6 weeks from submission. So it was I forget, here it was submitted 30th of August 2022, revised 28th of September 2022, accepted 12th of October 2022, 19th of October it's out. Like, this is clearly this got slipped through, and yeah, it's a real problem with peer review in that kind of sense, because I've never seen a paper get done that quickly for anything.
I mean, even when I've published months and months and months, like I don't know, something happened. I don't understand.
Yeah.
Maybe it was a special issue, because sometimes special issues, things can get slipped through. I don't know. I don't want to read into why or how. It just happened. So yeah, so the question is, like, to dig through kilometers of bedrock, like, how? Like, even now, that would be a project that would take years and years. And of course, they're going to say, well, it's clearly evidence of some mysterious ancient civilization that came before, which it did. The ancient Egyptians, like, we have evidence that they leveled that. So, for example, let's even do the math. All right. Devil's advocate, benefit of the doubt. What would the volume of 2 kilometers deep, whatever, hundreds and hundreds of meters by hundreds of meters wide of dense limestone and sandstone, what volume of earth would that be? Mountains, right? Mountains and mountains.
And on top of that, they're putting a structure made of rock inside bedrock. As I said yesterday or a few days ago, it's like, it's putting rock in rock. And like you said, we have evidence of the quarrying and the leveling and all this kind of stuff. And somehow this is going down 2 kilometers even below this. And another point that I made was, we also have a good understanding of groundwater at Giza. This is well below the water table. So they'd be underwater and drowned if there's this city that's 2 kilometers down. It would very clearly be underwater and drowned. And so it's just like, it's completely improbable. And then it's with methods that have not been demonstrated to be successful with known information in any way. And
look,
so,
the groundwater in Egypt is so problematic across the board. I mean, it was that way in antiquity. So when we've done work at Lisht, and my colleagues have done work at other sites, you dig down 5.2 meters at Lisht and the groundwater hits and you stop. That groundwater can come in, and people have drowned in archaeology because groundwater has rushed in and caused bulks to collapse. It is so dangerous. And in antiquity, some of the ancient Egyptian tomb shafts, on purpose, because of the connection with the Osiris myth and resurrection and annual flooding, they specifically put the king's burial beneath the water table, which also helped protect it against looting. They knew. The ancient Egyptians knew.
In fact, the new tomb that was just announced, they mentioned they had to move the body out and stuff like that to protect it because of flooding, because they went down to the groundwater level. And so this was a common issue, obviously, in the past. You're digging deep, you hit groundwater, right? That's going to happen.
Right.
So I don't think there's much that's going to convince us, I think, that this could be in any way legit.
It's funny, though. I posted online, like, with the cylinders and how big this was. It's that scene from Total Recall. I'm like, they found this from Total Recall. Like, that's exactly what they claim they found. They found the alien technology on Mars. It all matches up. It's there, except that's a movie.
Exactly. There we go.
All right, yes! We found it! We found it.
This is exactly what this is, in a sense, right? This is what they're showing, is there's those cylinders, and they're somehow larger than the Empire State Building, as some meme online said. The pyramid thingamabob was 648 kilometers tall. There's that, and somehow it is going all the way down here.
Hold on, there's an image. Hold on, I'm gonna see if I can find it. And it's like the real truth of the Giza pyramids, and it's actually like a cat ear, and there's a cat under the ground.
That was my thumbnail for the previous video. Yeah, I used that.
Let me see
if I can find it again. Is it this one? Yeah. So this is what we used for our thumbnail. for the previous one, which got lots of people to click.
Yes, it's the best.
The
It's
cat
the
ears. So this is what's actually there. I think we're in agreement. And
Yeah.
in fact, you promised me a special treat, which is that you have done some remote sensing on the Giza plateau. So,
Yeah.
and it's stuff that we can confirm and whatnot. So show us what you got.
So we've been doing, lots of remote sensing work over time. We of course have looked at the Giza plateau, and can remote sensing reveal anything that's there? We've kind of had to mask where this is.
Yeah, and what I love about this is, like, there's been so much work with remote sensing and excavation at Giza, so there's still so much more that can be done, right? It's really promising.
So in the Western Cemetery, we've been doing some processing, and I think there's excavation work here. So it's, again, but you can just see, just from basic satellite imagery, there's the hint of something here, and then you see how much it pops out. And then at Saqqara, so we have been able to use new Worldview 3 satellite, which has information in the middle infrared, which allows the geological deposits. Because near infrared is it's water detection, but the middle infrared allows you to discern different geological types. And you can see, again, you see maybe the subtle of something that's here, maybe some dips, but the mid infrared makes that really clear, and the same for this information. So again, at Saqqara, walking over, maybe you'd be able to see hints of these tombs, but using the mid-infrared, it's really, really clear. So like there's new stuff out there, right? Using new technologies at Giza and elsewhere, you can find different things in different places. And like I said, the Ministry of Antiquities has been excavating at Giza, and they keep finding new tombs. So I'm in the area where we did that satellite work years ago. So there's stuff that's there. We have to be critical of the satellite imagery. We have to show what it can and can't do, what the boundaries are, and also, like, okay, we found, we have found a tomb or a pyramid or a settlement or a wall in a place where there's lots of things like it. Maybe it's not as exciting as like a 4,000 foot deep, massive city, but you'd expect to find it. Like,
mentioned on the Emerald Tablets of Thoth, of course. Don't forget that.
yeah. I just, so I didn't think when I first saw this, maybe I was in the middle of proposal writing, it didn't register like satellites plus Egypt. I'm like, oh, that's kind of funky. And then I saw it going viral, and I thought, oh no, my inbox. Oh no. And I've gotten a couple pokes from friends of mine who are like, is this like, I don't think this passes the smell test. I'm like, no, it doesn't. So at least for now, it seems to have stayed out of most mainstream media, but I wonder with how viral it is, if it's gonna.
I mean, it's been in the Daily Mail. It's been in the Daily Express, the Express Tribune. It's been in, I've seen several scientists actually share it on Instagram and TikTok and YouTube, like people not in archaeology and not people that do satellite stuff. And so it really scares me how far this went. I've gotten a lot of comments from my previous live stream where I have had several where it's like, oh, I can't believe I was fooled by this. I thought this was legit the way it was shared, and now you've shown me why it's not. And so hopefully this conversation will help do a little more on that and reach some more people, because, you are, as I mentioned, you wrote the textbook on this stuff, and you even in the textbook, you described very clearly different examples of SAR and how it can work. And the example we used from Ostia, that was using the same Italian satellites that this current claims have used to make their claims. And so what they're doing is absolutely not standard, absolutely not tested. It would be an underwater city anyway, because it's under the groundwater. I guess that's why it's Atlantis. It's underwater, right? And so, so it's such a problematic thing, but somehow millions of people have already fallen for it in just a week. And it's kind of scary how our world works in that way.
It's wild to me, like all, just from folks I follow on social media, people otherwise pretty reasonable and critical of this stuff are super psyched and all. And like, even like some family members of mine texted me and they're like, hey, what do you think? I'm like, are you for real? Really? Like it seems to match up, right? You have scientists, you have a remote sensing person, you have a site where there could be a lot more there. And people are like, oh, that's amazing. Of course there's new stuff at Giza. And then you're like, can we talk through the likelihood of massive cylinders being 2 kilometers under the ground? Do you hear yourself right now? And they're like, oh yeah, that's not.
Yeah. And it just takes some obvious things, like it's just rock in rock. Why would you do that? Like, why would you put a rock structure in bedrock? Like, it's just, but yeah, people hear the fancy word salad, photonic, phononic, and satellite imagery, and then it is people with PhDs and stuff like that who are presenting this, and then all of a sudden it becomes sort of, it breaks down their guard, and I think that's part of the issue. And it's something I've been trying to build up towards one day, and I'll talk with you about it in the future, is I want to do kind of a documentary style video on the ways that pseudoarchaeology in particular uses remote sensing of various types, because I think that it's one of the really common sort of foils. We've seen it at Gunung Padang, with this sort of study of the pyramid and the geology, using different remote sensing type stuff. And I think it's just something that seems so fancy, and it produces images that then it's like a Rorschach test. You can see whatever you want in it, and then you can turn it into some fancy artwork like we saw with this one, that sort of have gone viral. And so it's just like, remote sensing is just perfect for this community that wants to share kind of bogus information, if you see what I mean.
And it's because when you have scientists who, like, I could willfully misinterpret a lot of data if I wanted to. I could say there's stuff here, make it seem like there's stuff there. And I have a reputation, for better or for worse, I have a reputation, and people would believe me, right? So with great power, or whatever power we have, great responsibility. And this guy who seems to have done decent remote sensing work, like, I don't understand, does he think like, satellite imagery, make grand announcements to the world, ... profit? Like, I don't understand. I don't understand what is he thinking? I don't know.
It's always tough to tell how willful some of this stuff is, because some people who are very smart also have very odd ideas about the world, let's say. And then, at the same, and especially when it's topics outside of their field. I've talked with plentiful scientists who don't really understand archaeology very much, and they think that they know more than people that do this as their job. And, we see this all the time. We joke about engineers or whatever coming in and looking at data that we've been looking at for centuries as a field. And it's just kind of like, yeah, it's a problem. It's a real problem. And the way this stuff spreads, there's this whole ecosystem of pseudoarchaeology, which, me and others, I think we're trying to build up a stronger ecosystem of real archaeology, where we can get more people like you to come on and tell us what's up, and what your research is, and what the problems are with some of this fake stuff. And at the same time, try to link with other sort of YouTubers and podcasters that are doing this from their perspective, that want to present real stuff. And so, I think that's our big goal, is we need to be loud, if you know what I mean.
I agree. You're doing such an incredible job. Although it's classic being a woman on the internet. I put out a skeet on Blue Sky, kind of debunking this, and I had about a half dozen guys whose comments I've now deleted. They're like, yeah, what do you know about remote sensing and archaeology? It's like, I so badly wanted to tweet Dunk and pull a Rebecca Solnit and be like, I'm the textbook, but I didn't. Yeah. I behaved, but please read my bio. Could you read my bio? Just
yeah, well,
I know, right? Typical, but yeah, I don't know. I don't know. Like, I certainly haven't gotten any messages from Joe Rogan or any of those guys to go on, but I don't know, would I go on if I were asked, like, just for them to be angry at me, and I walk them through satellite imagery and they're dismissive? I don't know. Like, I just think all of us need to be commenting more. I haven't had other Egyptologists comment on this yet. I don't know. And the problem is, there aren't a lot of Egyptologists, at least some, shall we say, a more senior generation, who are online. So they might not even be aware that this is happening. Or they may have gotten weird emails in their inbox and been like, oh, they're just crazy cranks.
Yeah.
That's not real. As opposed to, like, this was published 3 years ago in a really good academic journal, and it's going hyper viral. Y'all need to get on it.
Yeah, exactly.
So I haven't seen any from any of them yet, although I obviously could have missed something.
So I think Zahi published a statement saying that this was all bogus. But yeah, I mean, I think some of it is just from what I've seen from Facebook friends I have who are Egyptologists, they didn't even know about it. It's just it sort of went really, really viral on social media, and it'll take some time, I think, for it to percolate. But I imagine there'll be times where people need to comment because it's if you see what I mean, it's very, very viral. Like it's as you said, a lot of people have already mentioned it. Statement by Zahi Hawass on the fake news on Khafra Pyramid. I would like to make a statement regarding the news that was published all over the world by a group of amateurs. The news was under the Pyramid of Khafra at Giza. They found a platform topped with pillars. All this information is completely wrong and has absolutely no scientific basis. In addition, the Ministry of Tourism and Antiquity did not give permission to any individuals or institutions to work inside or outside the second pyramid. In addition, the claim that a radar was used inside the pyramid is false. I think that's just social media rumors. These people who announced this wrong information, they use techniques that are not approved nor validated. The details announced would never have been seen by using this technique. And so, you know, I think kudos to you for coming on. I think in this environment, we need more of us to be speaking up because there's just so much fake news out there with archaeology. And I think what it shows is so many people are interested in archaeology. So we all need to speak up and fill that void and try to share the real cool stuff that we have to share. So yeah, thank you. And
no, ever happy to. Thank you for having me on, and thank you for sharing the quote from Hawass. That's something I can point people to if I'm asked by anyone in media, because of course they need to speak to him as the former minister. But it's important. I wish more people would speak out. And again, like, I'm not dampening down on any of the enthusiasm. People are hungry for new discoveries, right? Amazing new discovery of a new royal tomb in the Valley of the Kings. Great team doing great work. Methodology approved by the ministry, highest levels of work, like, and they're all just excited for Dr. Leafland, and they're awesome. But like, that's great. It's how it should be. And we're all of us in the field. So if there are people listening who are like, oh, you just, you know, you're crapping on a discovery because you want the credit. Like, no, I want all my colleagues to make amazing discoveries. I want them all to get kudos and headlines and funded, and like, I want that for them. We all want that for each other. Like, our field, as much as we want, all of us, when this stuff happens.
And we love to work with the public. I've always mentioned how I've worked with plenty of amateurs, and you've done a big citizen science stuff in your past, right? Where you've gotten people on the internet to contribute by scrolling through satellite imagery and stuff like that, right?
Yeah, we had over 100,000 years from nearly every country in the world, looking at millions of satellite images in Peru. And they found, this is the public, right? This is not me. They found 29,000 features, which we determined to be anthropogenic. We were very cool. We then, you know, parsed through it, looked carefully, and there were over 800 sites, which we shared with our colleagues in Peru, that they determined to be major sites of archaeological interest. So Inca, Chima, Moche, you know, the full range of site types. So the crowd found that. They spent months and months and months looking at imagery. So, and again, that's the right way to do it, right? We created the system, we did training, they found the things, we parsed it, experts looked at it, and experts in the archaeology of Peru confirmed what the crowd had found. So like, that's great. We need the public to be more engaged. We need to give people more opportunities, and they're really good at this stuff.
Yeah. And I think there's plenty of opportunities out there. So if you're interested in archaeology, I highly recommend looking into local archaeology around you, looking into online citizen science stuff, because there's other initiatives that are being done either in your neighborhood or online that you can do this kind of stuff. Because we love it when people are interested in what we do. We just don't like to see this kind of abuse of our field, I guess is the right way to put it.
Yeah, it is, because it's a mess. It creates, it's like, if I may be blunt, speaking of a cat reference, a pile of cat vomit carpet. And you're like, really? Did you have to barf in the middle? There was a wooden floor over there. And it's like we step in it. Oh, really? Really? It's a mess. We have to clean it up. It's really, cat. So don't barf on our carpets, please. No more. I don't want to clean up your messes. You guys who wrote this paper, don't barf on my carpet again, or I will curse you. And my curses are real. So you want to mess with this?
All right. Well, that's a perfect ending. Thank you so much, Dr. Parcak. It was a pleasure.
Thank you.
And we'll have you back on again when your new book comes out for sure. in the future.
So I look forward to it. Thank you.
Rhymes and riddles, tickle, tickle, giggles, squiggle, jiggle, fiddle, flint, pun, dibble.